My name is Roxane Van Mellaert. I'm Diabatix Head of Operations and your host for our X in-depth video series. Our virtual engineer X uses artificial intelligence to create high-performance generative thermal designs. Today, I'll explain what generative thermal design is and how we combine it with artificial intelligence to achieve fast and optimal design results. Generative thermal design is an iterative process. The idea behind it is that each new design iteration becomes better than the previous one, with the process continuing until the optimal outcome is reached. This process can be done using classic trial and error, which is a common approach in the world of thermal design today. The problem with this approach is that it cannot guarantee an optimal outcome, and it can be quite time-consuming, as you will see in a moment. By using artificial intelligence like our virtual engineer does, this process is both fast and optimal. Here's an example of both design methods in action. Both design approaches start with an empty heatsink that has no channel structure, like here. Then a case setup with boundary conditions, constraints, and optimization goals is defined. So in this case, we have an empty heatsink with an inlet and an outlet. The goal is to maximize the temperature uniformity with a pressure drop constraint. From here, when the actual design work begins, the approaches go their separate ways. In the conventional trial and error approach, as seen above, a thermal engineer will create a design, simulate it, create a new design and hopes that it's better than the previous one, simulate it again, and so on, until a design is reached that is satisfying him. So to give you some context, a thermal engineer typically creates a handful of designs with this approach. In an AI-driven approach, as seen below, thousands of design iterations are calculated until the most optimal one is found. What's incredible about the AI approach is that these thousands of design iterations can happen within the same time frame of one design iteration in a conventional approach. At Diabatix, we use an artificially intelligent approach to generative thermal design to create unique manufacturer-ready heatsinks for applications where cooling is absolutely critical. For example, in electric vehicle batteries, e-motors, power electronics, and so on. The main reason for that is the design freedom we have thanks to our approach. We aren't bound by conventional shape requirements like S and fin shapes or trial and error process, so we possess both the liberty and speed to create optimal design geometries that go beyond human imagination, literally. I hope you enjoyed learning about our AI-driven generative thermal design process. In our next X in-depth video, we'll go over the engineering design algorithm that's behind our virtual engineer. Stay tuned by subscribing to our YouTube channel. Thanks for watching and see you on the next X in-depth.